Welcome back. This is lesson 15 of Machine Learning Zoomcamp session 2. In the previous lesson, we found the best parameter for our linear regression. And in this lesson, we will train the final model and use it. And by training the final model, I mean, remember that we have a data set that we split it into three parts. So we had a train data set, we have a validation data set, and we have a test data set. So far, what we were doing is we were training our model on the training data set, applying this to validation, and then getting our RMSE from that. What we want to do now is, instead of that, we want to train a model on the entire part that we use for both training and validation. We can call it, for example, full train or something like this. So we train a model on this one, and then we make the final evaluation on the test data set to make sure that our model works fine, and we check what is RMSE on that. So it shouldn't be too different from what we saw on the validation data set. So let's do that. So first of all, what we need to do now is get our data. So what we have is, remember, we have this data frame train, and we have data frame test. These are, data frame validation. These are the two data sets we have. What we want to do is combine them now into one data set. And for that, we use a function called in pandas, called concat, that is short for concatenate. It takes a list of data frames, and what it does, it concatenates them together. So let's call it full train. Let's see, full train. But if we print the entire data set, we see that even though there are 9,500 rows, so we still have the index from the validation data set. What we can do is just reset index. We write it back. And now we shouldn't have this problem. Yeah, so now everything is sequential. And we can use that now to get our feature matrix. Let's call it full train as well. Remember, we have this prepare X function that we just use here, right? And so we have our feature matrix. We also need to train a model. We also need the Y. And again, there is a function in NumPy also called concat. No, it's called concatenate. So there is a function in NumPy called concatenate that does exactly the same thing. So we just need to concatenate Y train and Y validation. So there is no index here. That's why we don't need to reset anything. And let's call it also Y full train. And now we take this code for training the model, and we replace this X train with X full train, Y train with Y full train, and then this R, it was 0.01, yes. And we train our model. This is our final model. So these are the weights of the model. And so what we need to do now is prepare our training, our testing data set, and we will do it exactly in the same way as, we will do it exactly in the same way as we do the validation data set, except we will just replace validation with train, with test, sorry. So we get test, then we'll multiply here, and then we get the score, and we need to check it with a Y test. And we see that our model is not too different from what we had previously. In fact, it has almost the same RMSE, like up to third decimal point, which is a very good sign. It means that our model is, it can generalize well. So it didn't get this score just by chance. So it's good. So we have this final model, and now what we can do is we can use it. The way we want to use it is we actually want to use it to predict the price of a car. So imagine that there is a car, and we want to understand what's the price of this car. So we extract all the features. So we get this feature vector from the car, and then we need to put it into our model, right? And then it should predict the price. So this is what we want to do now. So this is our final model. This is our final model, and we want to use it to predict the price of a car. Let's see how we can do this. So for that, we can take any car from our test data set and pretend it's a new car. And this is fine because we haven't seen this car during training. So we didn't train our model on this data. So here we have Toyota Sienna, and yes, there are missing values. Usually the way we do it, we don't get a data frame here, like when we extract some features. So it could be some Python dictionary with all the information about the car. So let's say in real life scenario, it could be a website or an app, right, where people enter all these values about the car, like Toyota, Sienna, and then the website sends a request with all this information to a model, and then model replies back with the price. And so this is what we want to do now. So for that, we need to turn this into a dictionary, because this is how usually the requests look like. Let's say car. So this is our request with a car. Like we know all these values. Yeah. So now we want to put it in a model, and for that we need again to turn this, because remember our prepare x function, it expects a data frame. So we need to turn this this dictionary. And remember, we pretend that this dictionary is coming from the user. We pretend that we didn't just extract it from a data frame. So we need to put this prepare x expects a data frame. So for that, we can just create a small data frame with a single row. And for that, we use this pandas data frame. And then we can pass a list of objects, a list of dictionaries. And this list will just contain one single car, which will be the car we just received in our request. So we have this car. And then this car can go to our prepareX function. Yeah, so we get a feature matrix with just one row. Let's call it x small again. Right, so we have that. And this is how we get predictions for that car. So here, instead of x_test, we use this feature matrix. And let's see immediately what are the results. So the results is 10.6. So that's actually what we need. Is we just need the first number, right? So for this car, so there is just one single car, right? So we don't need an array, we just need one prediction. And what we need to do now, remember that this is the logarithm of the price. So what we need to do now is take the exponent. So this will undo the logarithm. And this is actually the prediction. So we think that the car with these characteristics should cost that much. And let's see how this car actually costs. So it's number 20. So we can see y test number 20. Yeah, it's reasonably close. Let's see what happens when we undo the logarithm transformation. Yeah, so here we see that our prediction was a bit off by 5,000. I think it's a relatively good prediction. Yep, so this is how we can first train a full model, and then this is how we apply this model to predict the price of a single car. That's all for this lesson, and in the next one we will have a summary.